So, we are going to do today about the green supply chain ecosystem analysis. As we said in the last class, we said the objective of green supply chain ecosystem is to meet the present needs without compromising the future. So, since supply chains are basically the generators of both products and services, it is important the supply chain need to be green, and we have gone through several basics of green supply chain analysis. What we are going to do today is map the ecosystem for a green supply chain, and it considerably differs from the ecosystem of the ordinary supply chain, because there are several new things that are added in addition to being the supply chain in the analysis. So let us see in the next 1 hour how to map the supply chain here. So the contents of these 2 lectures are we map the green ecosystem supply chain, and there is the forward backward supply chains. Basically in ordinary supply chains we have only the forward supply chain, that is, it basically goes from the suppliers to the consumers. Whereas in the green supply chain there is what is called a recycling. In other words, the products that are disposed of by the customers, they will get back to in the form of materials or refurbishment and so on, go back into the supply chain. We'll look at that, and then what is the delivery infrastructure here. In addition to the ordinary supply chain, which has inbound, outbound logistics and the software and all that, in the green supply chain, we have what is called a reverse logistics. So, also we'll look at what are the kinds of regulations that affect the green supply chain. Actually, the regulations certainly have an effect on the functioning of the green supply chain. And resource minimization, whatever the resources, whether it is water, land or something, and then maintaining the quality of the resources without polluting them is one of the fundamental aims of green supply chain. So we'll look at the reports and also the talent that is required for the green supply chain management is much different from than the ordinary supply chains. So the talent, which is the human talent, is different, and we will see how as the green supply chain movement picks up, what is the kind of talent that is needed. Well, the second half of this lecture, we will do the GRIP framework. This is the performance, innovation, risk and governance, and we will conclude the lecture with that. So let us look at the green supply chain map now. So the green supply chain ecosystem is basically you have the green supply chain ecosystem, and of course the supply chain resources, institutions and delivery service mechanisms. Here you have basically innovations. We have co-evolution of innovations and as well as the risk propagation. You should understand the co-evolution. For any evolution of the green supply chain, you require the cooperation of all the partners. It has to be a collaborative effort between the government and all this one. If you want to save resources or keep them well up without polluting them, and the institutions, you require government regulations, and of course you require delivery mechanisms like the transportation and others, which has to be green. That means they have to be free from the greenhouse gases, and also the supply chain partners should collaborate. It's not enough if the supply chain manufacturer or distributor is green, you have to have every partner in the supply chain to be green. So the co-evolution comes like this. The resources are getting depleted or getting polluted. So the social people, the people or the social groups, they get into the act, and government makes a resolution saying that it has to be the green has to be followed and should not be polluted and all that. Then the supply chains start acting, and of course the green delivery and all this comes in, and all the people have to cooperate. So it generated from somewhere from the resources pollution, and people complaining about it and asking for better resource management here by the companies. It goes into the government, and then it basically gets as a resolution by the government to basically to start this one. So it's basically a co-evolution. Similarly, the risk propagates even as in the ordinary supply chains, even here. So let us look at each of these chains, and we'll come back to the risk issues later. What are the forward backward supply chains? So the green supply chain ecosystem map is, we have the purchasing or the procurement, which is the business process, and then we have the manufacturing process, we have distribution and retail. These are the three important processes in any supply chain, and we have the GHG gases estimation. This is, as we said before, that it is important to measure before you monitor and you control, and also reuse, recycling, remanufacturing, refurbishing, and so on. These are all the things that forward and backward supply chains here. Now the forward supply chain, as usual, is purchasing, manufacturing, and distribution and retail. This is what we usually consider, but here the reuse, recycling, and remanufacturing is this. As we know already that for example, the procurement or purchasing has its own supply chain. In other words, it has to identify the suppliers, procure, identify the logistics providers, tell who produces what, and finally how much is required, and arrange for the delivery to the manufacturing site. And similarly, the manufacturing, whether it is multi-site or single-site manufacturing, it goes on after the manufacturing is finished, it goes to the distribution and retail. So each of these have their own ecosystems, and reuse, recycling, and remanufacturing is an important part of the green supply chain. So we'll look at that. And the institutions play a fundamental role. They are regulatory bodies which regulate on, it can be carbon credits or it can be GHG gas limits, whatever, and the gas emissions and ISO certification, and central and state governments, and citizen groups, social activists, and NGOs, and business organizations. So these are basically the institutions that whose support is needed for the green supply chain management. So basically it's an important that we consider the institutions and their role in the green supply chain. Now, in terms of the resources, you have land resources, you have water, power resources, you have various industry clusters, infrastructure, ports, roads, airports, and rail, and there is the carbon trade. Carbon trading mechanism, it becomes a resource for a new resource for the green supply chain. Of course, there are financial supply chains, smart and green technology innovation. You require educational institutions to do research on how to use ICT to make these smart technologies and then also make them green and so on. So, and also if you look at the delivery mechanisms, you have inbound, outbound logistics. We have an additional reverse logistics. Reverse logistics is basically takes from the consumer back to the supplier. Transportation and communication, these are both of them emit a lot of GHG gases. So transportation, we require green transportation, waste disposal and recycling, because whatever waste, either municipal waste or it's the industrial waste, the waste has to be recycled before it actually spoils the resources. and lot of training that is needed for the staff, because you are talking basically of new technologies, you are talking of new innovations, you are talking of new practices. So you require to train the staff. So basically, if you look at the green supply chain ecosystem, you have the 4 elements: the forward, backward supply chains, the resources, institutions, and delivery mechanisms. All these affect the green supply chain performance. So let us look at one by one. The forward, backward supply chains. Or the green supply chain management is basically green purchasing plus green manufacturing plus green distribution plus repair, reuse, remanufacturing, and recycling. So there are 4 Re's that are important. So these repair, reuse, remanufacturing, and recycling, these are the 4 important things, and they form the backward or the reverse supply chain. And of course, we have to have even the purchasing, it has to be green, the green manufacturing has to be green, and the distribution need to be green. And the forward reverse supply chain has dual objectives. Now, the forward supply chain optimizes cost and performance of all the processes from product design to customer delivery. That's the primary objective of the supply chain. That is what the forward supply chain takes care of. You take care of the supply demand matching, you take care of the lead times, you take care of the low cost requirements of the customers and make them available in the stores wherever, and so on. So basically, the requirements of the forward supply chain, they remain the same. But in addition, we are dealing with a backward supply chain that optimizes the environmental performance of the forward supply chain. So in other words, if you are using a resource, the backward supply chain need to look at how to minimize the use of those resources. And if you are using some electric power, you have to basically, the backward supply chain looks at how to make that power green. If you are using coal-fired plants, how can you use solar power, or can you use windmills? How do you actually manage the power supplies to be green? So there are various issues that are connected with the green issues, and all that becomes a responsibility of the backward supply chain. I mean, the backward supply chain is important even without the green regulations, because it actually optimizes the use of resources, optimizes actually the use of the delivery mechanisms, minimizes the cost, and so on. So the dual objectives becomes very important here. And the features the features in the supply chain design include recycling, which is collecting used materials, disassembling into materials, metal, plastic, glass, and processing them. So what do you mean by processing them? Either you make into raw material and feed it back into the supply chain to the suppliers, or you can basically dispose it off, or you can disassemble them and use some of the parts which are useful as spare parts for the materials for repair. Second one is reuse, which is collecting used products from the field and selling them at reduced prices. So this is basically in the electronic arena for all the laptops, cell phones, and so on. This is becoming a big thing. You collect all the used products from the field and repair them, refurbish them, and sell them at reduced prices. And remanufacturing is collecting used product, repair, and test for quality before use. That is the remanufacturing. So materials and components required from used products re-enter the same forward supply chain along with new materials or components. So the re-features become very important. Of course, we didn't consider the repair is a part of remanufacturing, but whatever the materials are there, we'll see in the future slides how these things enter into the forward supply chain. So what are the green business processes? One is green procurement, that is acquisition of products and services that minimize the environmental impact over the life cycle of manufacturing, transportation, use and recycling and disposal. So basically it's the acquisition of products and services, and green manufacturing is production processes using efficient inputs, energy efficient technologies that generate little waste or pollution and have low environmental impact. So it's very important that the manufacturing follows all these three principles, that is little waste, low environmental impact and energy efficient technologies. And so basically you have to use these three. Inbound logistics is very important. Basically it delivers from all the suppliers to the manufacturers, and the transport mode selection, in other words, which is the transport you are using, rail or ship or truck or air, whatever. So you should have the carbon footprint of the transport mode and select it properly. Rail and barge are more energy efficient than road haulage or air cargo. So depending on your time requirements, you have to, and other requirements, you have to basically give care to the mode selection. Outbound logistics is basically from the manufacturer to the distribution centers to the retailers. Criteria for green logistics such as fewer shipments, less handling, shorter movements, more direct routes and better space utilization, trade-off with the delivery time, responsiveness, quality and cost. So basically you should see that there is a conflict here. Whenever you want it to be green, you want to keep the inventory because you want less number of deliveries. More number of deliveries means less inventory and just in time, but that means you are spending more carbon in your transportation. But on the other hand, if you have fewer shipments and less handling and shorter movements, more direct routes and better space utilization, they trade off with delivery time. So basically the time responsiveness, quality, cost and delivery time, they basically have a conflict with the green requirements. So anyway, conflict is a part of the game. So you have to basically look at the optimization of one versus the other. So what is green procurement? Green procurement is purchasing, includes vendor selection, material selection, outsourcing, negotiation, buying, delivery scheduling and so on. And green procurement is the selection and acquisition of products and services that minimize negative environmental impact over the life cycle of manufacturing, transportation and recycling or disposal. In other words, if you take the product life cycle, it involves manufacturing, transportation, use, recycling and disposal, right? So all this you have to minimize the negative environmental impact over this life cycle of the product. And examples of environmentally preferable characteristics are products and services that conserve energy and water, minimize generation of waste and release of pollutants, products made from recycling materials and those can be used and recycled, energy from renewable sources that are biofuel, solar and wind, alternate fuel vehicles, products using alternatives to hazardous and toxic chemicals, radioactive materials, and biohazardous agents. So, I mean, these are easily said than done, but they are environmentally preferable alternatives. So, the big point here is, whenever you are designing your system, design the product so that whatever goes into the product is recyclable. In other words, you can easily extract after the product dies, it is disposed of, you can easily extract the materials from there, first thing. And second thing is, while manufacturing, use as little resources as possible. And thirdly, while during the entire life cycle of from design to the use and so on, minimize the environmental impact. So, inbound logistics is basically the just-in-time practice is to lessen the amount of inventory by delivering in small batches, less warehousing, and more fuel consumption and traffic congestion. Traffic congestion because the vehicles are moving. If the supplier is outside the city, in one part of the city, and the manufacturer is another part of the city, then these vehicles will be moving around. And freight consolidation, full load freight delivery may lead to longer lead times, but environmentally preferable. In other words, if you want to wait till the truck is full loaded, it may take a week. So that means you have to keep 1 week inventory. So, but it is longer lead times. But you are basically making less trips, so it is environmentally friendly. The transport mode decision affects the traffic congestion and air pollution, both directly and indirectly. Rail and barge use more efficient than road haulage. So, but of course, you have road haulage has a more flexibility. It can directly take it to the site, to the factory site. The truck can go to the factory site. Whereas if it is train, you have to take from this train station. You have to haul it to by a truck, and there is loading, unloading, and all these factors. So basically, there are the issue of timing and speed and cost and so many manual handlings and so on. So it is green manufacturing is basically production process should be highly efficient inputs. Now, for example, we have seen in case of cement, it has to work at 1400 degrees centigrade, and same thing happens with the refineries and the steel factories and so on. So these inputs, energy efficient technologies that relatively low environmental impact and generate little waste or pollution. So particularly in the continuous processes, or even in factories like auto and so on, all the components, auto components need to be produced from steel, and steel becomes a steel becomes a basic material for this. So if you look at the car, the automobile green gases that are emitted during the entire production process, you have to consider the steel, you have to consider during the manufacturing and so on. So basically, the production process should be highly efficient inputs and energy efficient. Quality control at vendor site and before processing of all inputs, and concentration on high percentage of recyclability and recoverability. So it can lead to lower costs, reduced environmental safety and expenses, and improved corporate image. So green manufacturing is important, but takes time. Similarly, distribution and outbound logistics is the movement of finished products from production to consumer. And the typical outbound logistics decisions, either you want to ship directly or you want to use hub and spoke. Well, if you want to directly ship, then you need more vehicles, and they may be half truckloads, they may not be full truckloads. But on the other hand, if you use hub and spoke, and then all the vehicles take them there, and then you can basically manage the full truckloads, and central warehousing or a distributed network, intermodal or single mode, third party services or private fleet. So, you want your own fleet or you want to use third party services. So, these are basically the outbound logistics decisions, and you have to see which one is green, while at the same time which one is efficient, which is low lead times and also low cost. Outbound logistics criteria that support environmental planning include fewer shipments, less handling, shorter movements, more direct routes, and better space utilization. So, but each of these trade off with delivery time, responsiveness, quality, and cost. So, you can always see the conflict between your responsiveness, delivery time, cost, and so on with your green criteria. So, if you want a very efficient system and you want to follow JIT, TQM, whatever processes that you are following earlier and keep less inventories and so on, then you may end up with a less green this one. If you want to keep clean, then you have to innovate yourself how to meet both objectives and meet both the criteria, and how do you actually resolve the conflicts. The conflict resolution is a big issue. So, if you look at the delivery infrastructure, the delivery infrastructure is the reverse logistics here, and in the reverse logistics we have the process of retrieving the product from the end consumer, and it includes collection, sorting, reprocessing, redistribution, and disposal. I think one should understand that the reverse logistics is a highly complex process compared to the inbound logistics. The inbound or distribution logistics that we have is a planned activity. In other words, you know how much material is moving in advance, from how much is coming from the supplier, how many trucks you need, when and where and so on, and when it is needed at the other end at the manufacturing site. But in the reverse logistics case, you are basically taking products which are disposed of by the consumer. So, the consumer, what is the probability that a consumer disposes of the product? And you have to collect it, you have to sort out, you have to reprocess, redistribute, and finally you dispose of some of the things, and then you have to basically reprocess some of this stuff. So, reverse logistics competency is a competency that does not exist in most OEMs or 3PLs. So, for example, most of the OEMs, original equipment manufacturers, they basically handle their own logistics. They have private fleet, and they own their own drivers, and they have their own logistics department, and they manage their own logistics. But here, the reverse logistics, are you going to manage the same or you want to outsource it? But here it all depends on this one. We are going to see 2 or 3 examples where both are possible, but outsourcing is much common here. Why? It's because, how do you know the customer has disposed of? And the site, where does the customer dispose it of? He disposes it of maybe nearby his house. So, you have to basically collect all those, and you have to sort what it is, and the customer may dispose it of in his junkyard so many items. So, you have to sort them, and you have to basically reprocess and so on. So, basically the reverse logistics is a competency that is not this one, but what one need to do is to look at what is the kind of product we are dealing with. Now, for example, if you are dealing with laptops or something, then the reprocessing is easy. In other words, the reverse logistics, it comes from services and so on. But on the other hand, if you are dealing with some products which are not worthy, then it becomes reverse logistics becomes this one. So the stronger the pooling ability held by the third party over the manufacturer in reverse logistics, the more suitable it is for the third party to manage the reverse supply chain. So here, in other words, do you want to outsource or you want to do it yourself? This is the question that is often faced in the reverse logistics. So it depends the amount of business that you have, and do you have the competencies to do this, and do you have the scale? In other words, if you have products which are sold somewhere and it is not enough to maintain the reverse logistics capability, you don't have enough volumes to keep your reverse logistics people and the equipment busy, it may not be worth it. But on the other hand, if you give it outsource this to a third party, then he can pool from several manufacturers and then he can get the scale. So reverse logistics is now just coming up, and it is a competency that need to be improved in the name of the green, this one. So if you look at this one, reverse distribution costs may be higher than moving the product from producer to consumer. Now it is the reverse because in the when you are moving the products from the producer to the consumer, you are basically dealing with a almost deterministic situation. In other words, you know how much consumer or the retail shops need, you know when they need, and you know where the material is available, whether it is in the manufacturing site or a distribution center and so on. So you can plan your transportation from end to end using but in the reverse distribution, you are basically, there is a lot of uncertainty associated with this, because it has to move from consumer back to the producer, and in getting from consumer to the producer, you have a lot of uncertainty. You don't know when the consumer is going to dispose it off and how many consumers are going to dispose it off, and from any particular location you need to have enough volumes to take it back. And these are the issues that will increase the cost if you want to do the recycling. And return good flows are difficult to forecast and cannot be transported, stored and handled in the same manner as the forward channel. In the forward channel, you are talking of finished goods, which are basically to be sold to the consumer. They are well packaged and they are well identified with either RFID tags or labels. But that is the forward channel, it is easy to handle. Most logistics companies are ill equipped to handle the reverse product movement. That's because you don't know where the product is, you don't know who is the manufacturer, and several other issues, because the labels may have gone. So, and also you don't know how to disassemble the whole thing and then make it into products and all that. There are lots of decisions that need to be done. So for the retailers, particularly dealing with returns, product returns, and also the products which are basically after disposed of. So these are fundamentally two different things. Product returns are the ones that are returned. Somebody buys a product and afterwards he returns it, although in a good condition, saying that he didn't like it. But on the other hand, the disposed of products are the ones, the material or the product is not working, it's not functioning, and you are returning it, you are throwing it away as junk. So These are all issues with the reverse logistics, and tools and models for disassembly, scheduling, planning and control are still in their infancy. Well, one can see the issue about why it is still in its infancy. The reason is that it's a complex problem, and people never cared for this because it is complex and it is not worth, people thought that it is not worth their time. But now with the green environmental regulations, people are caring about the reverse logistics. So, reverse logistics in auto, aero and computers. Now, let us look at 3 examples. Car manufacturers, they invest and manage their reverse supply chain, managing thousands of different parts across hundreds of car models. The car models change every year, and the cars, they need repair, so you need spare parts for them, and the spare parts are much more expensive than the original parts. So, in automotive manufacturers, they try to basically keep the reverse logistics with them. The spare part market enjoys much higher margin and a source of higher profits, whereas and also in the forward direction they make only 5% this one, because there is a steep competition and low profit margins. So, it is a typical situation that you have the volumes are large in auto manufacturing, and spare parts business is very good, very highly profitable, and you basically in the forward direction you make only 5% of your profit. So, the servicing, the reverse logistics is much more profitable. So, car manufacturers, they try to keep their reverse logistics along within their company, or basically a subsidiary which handles most of it. So, you will find that most of the service manufacturers, most of the car manufacturers have their own dealers doing the servicing. The aircrafts, for example, are basically there are less competition, 4 or 5 of them, Boeing, Airbus and others. They have a technology advantage and they enjoy high profits because of limited competition, and the manufacturers pass the spare parts management to 3PLs. So, it becomes difficult. Sometimes the aircraft itself carries some of the spare parts, but the spare parts sometimes need to be airlifted from some place. So, basically somebody like FedEx and others, they manage the spare parts management for the aircrafts, and they have identify regional centers for warehousing the spare parts, and they basically manage from there. And in the consumer electronics sector, the demand for refurbished computers is growing, and they are sold at cheaper prices by all leading brands, and reverse logistics is outsourced. Now, here there is basically a brand because the original product is expensive, and a refurbished product you get it almost like 1/5 or 1/10 the price, and so basically people may prefer to buy the chip because it is cheaper, and reverse logistics is outsourced. So, let us look at the institutions here. The institutions in this one, their role in the green supply chain is a very important this one, because environmental regulations, every company, every individual need to follow these regulations. Clean Air Act, the Clean Water Act, the Toxic Substances Act, Comprehensive Environmental Response, Compensation and Liability Act are adopted in several countries. So, these are the laws which industries and individuals need to follow. And legislation on products, energy usage motivate GS and research. Green supply chain research is basically motivated by the legislation on products and energy usage. ISO 14000 series provide guidelines and standards towards ecologically sustainable business practices. So, there are standards available, and the price of emissions can include taxes. So, the government can tax credits if you do less carbon emissions, and subsidize directly related to emissions or indirect emissions pricing such as fuel charges. So, the issue is the government can interfere in several ways. This is through the environmental legislations or prices of emissions like carbon taxes and so on, and tax credits, cap and trade we have seen. So, the institutions play a central role in the green supply chain. And in fact, in most of the cases, the institutions, and in the name of course, the global warming, the institutions and the WTO and World Health and other organizations are responsible for this one. So, let us look at the resources that are needed, which is the very important element. Industries influence the environment in 8 major stress categories. They use the raw materials, they use energy, they use water, they use land, atmospheric generate emissions, water effluents, and production of soil waste and other releases. So, the raw materials or resource usage is raw materials, energy, water and land. And in terms of pollutants, it is atmospheric emissions, water effluents, production, solid waste and other releases. So, there are 8 ways in which the industry influences the environment. Use of land, competition with other activities such as agriculture, use of virgin land, forests, wetlands and coastal areas, and there is typically a lot of biodiversity loss. So, the industry is basically creating a problem because it is using the land, and which is, if it is a virgin land, it is helping the atmosphere, whereas here it pollutes the environment. And massive use of non-renewable natural resources. Pollution during the transportation and manufacturing, consumption of water and pollution of water reserves, generation of waste, high energy consumption in product making, and both in product making and usage. So, these are all basically the usage of the resources. So, cradle to grave and cradle to cradle protocols. You have to use either the cradle to grave protocol, where you use less resources when the product is using, or cradle to cradle is where you generate a project and after the product dies or disposed of, it comes back and through for remanufacturing, reuse and so on through reverse logistics. So, there are also resources like carbon markets. So, carbon markets use cap and trade scheme. We have seen this the cap and trade scheme, which has 4 basic components. It is government set a cap on the total volume of emissions of the pollutant, and these allowances are distributed for free or sold to the firms, and the allowances can then be traded in the carbon market. That is, the firms that would face high costs to reduce their emissions will buy allowances from firms with lower cost, thus reducing the total cost of emission reductions. So, it becomes a big trade, although the amount, once you have a cap, and that cap has to be met, but not individually by the companies, every company, but collectively by a set of companies. The emissions are monitored and reported at the end of the accounting year. So, it's basically there is a 1 year time frame during which these are monitored and reported. So, the largest carbon market is the European Union emissions trading scheme. So, there are a lot of trading that happens in the European Union. So, we'll look at the talent for this. So, this material is, there is a skills for green jobs, a global view, there is a report, you can look at that. The transition to greener economy has enormous potential to create both direct and indirect employment. Green restructuring. Basically, you have to train workers and enterprises to move from declining to growing sectors and occupations. Increase in the wind and solar power and decline in the production and use of fossil fuels. So, you have to train more and more people in wind and solar power generation. And new occupations, provision of training courses in emerging occupations, scientists, engineers, technicians, management of energy efficiency and waste in buildings. For example, there are the smart buildings, smart grid, there are a lot of things which are coming up, and these are new areas which require a lot of research. And also, once things have been built, you need technicians to maintain them and also manage them. So, greening the existing jobs. For example, in the automotive industry, workers across a range of jobs from engineering design to assembly line will have to work with the new fuel efficient technologies. Well, if you are working with petrol engines, now you have to basically work with the battery fired, battery driven cars, then you should see what it means. Basically, instead of petrol stations, you need battery charging stations. Farmers will have to adjust to more severe drought conditions, requiring them to learn how to grow new crops or new methods of producing the same crops. One thing is to complain about drought and global warming. Another thing is to find out, look, I have a drought, I have the land, piece of land, what crops can I grow in this, in the face of droughts which doesn't require much water? Or how do I produce the same crop with less water? So, these are the kinds of issues that people have to consider, and you require a lot of talent for this. All three sources of change alter the skill profiles and occupations, and that's the training needs. So, we see that whatever is the green revolution that we are talking about, it requires tremendous amount of skill sets, and we need to train these people for this. So, although people talk about green, this training and other kinds of things people have not used. I don't know whether the governments and everybody takes this very seriously so far. So, one should look at this. Supposing you spend a lot of time and money and to make a green supply chain. As we have seen, we have forward, backward logistics. We have forward supply chain, backward supply chain. We have a lot of regulations. You have to use less resources, find new resources which are environmentally friendly, spend a lot of time getting talent and all that. So, why should the supply chain owners do this? And what do they get in return? So, if you look at that, the supply chain becomes highly competitive. Now, when do you become a competitive supply chain? It becomes if nobody can imitate you so easily. So, if you are able to manage your supply chain which is green, and if your customers like your products, you have a competitive advantage against over the people who are manufacturing these products which are not green. And when you are doing well, it is always obvious that other people, your competitors, also want to enter into the same arena. They also want to become green. But is it easy? So, supply chains which integrate economic, social and environmental concerns are more difficult to replicate, because you have to spend hard time and your relationships with people to basically integrate all these economic, social, the triple bottom lines into economic, social and environmental considerations, particularly if suppliers devote asset specific investments to engage in the design of products and processes that use low resources, carbon friendly energy resources, care for disassembly and reuse activities of their customers, and developed higher levels of trust. So, if you have suppliers or partners who does all these things for you to generate products which are refurbishable, to generate products which are reusable and easily disassemblable, then and you have high levels of trust. I mean, while this is difficult, if you can manage this, then you become a highly competitive green supply chain, and it is not easy to basically take you off and try to compete with you in this, because there are a lot of asset specific investments that your customers have made, because wherever they are using coal power, they are using solar power, they have to integrate solar power into their system. All this takes asset specific investments. So, once they do all this, then they become highly competitive, but all this requires lot of effort.